Hi, my name is Matt Maxwell, and I'm a product manager for the Tektronix real-time spectrum analyzers. And I'd like to show you a quick how-to video for doing Bluetooth pre-compliance checks on a Bluetooth device. In this case, I've got a demo board here available, and I'm going to do the test with this RSA 607A real-time spectrum analyzer. It's a USB analyzer that's connected to my PC. The PC will be running SignalView PC software to control the analyzer. EMI compliance and EMI in general is a fairly broad topic. There's a lot of things that we could talk about with EMI, but particularly here I want to focus on sort of in the lab EMI pre-compliance checks, which are possible to do provided you have good enough shielding from the outside RF environment so you don't run into problems causing false failures of your device under test. So let's get started. So for the first test, I'm using SignalView PC software where the displays are organized into different folders. Within the Bluetooth personality, the Bluetooth application, I've got the Bluetooth in-band emissions test. So I'm going to add that. And I see it looks like it's kind of hopping around. What I have here is like a Bluetooth low energy measurement, and in order to change that, I need to turn on the averaging here. So I'm going to do some frequency domain averaging and turn up the number of averages to 20 so that I'm average. Basically what was happening is because this is bursted, sometimes the sweep would occur without a signal being present and it would cause it to hop around. Once I turn on averaging to average multiple traces, I always have at least one burst set up within this 81 megahertz bandwidth to look at all the Bluetooth channels around the 2.4 gigahertz band. So that's an important test to make sure basically that you're not interfering with other users of the ISM band with your device. And there the averaging didn't work, so it hopped around and searched for it again. By the way, this averaging problem goes away if I use the DPX display, the real-time display that's available here, but I don't have that available within this in-band emissions test. It's just the basic spectrum display. So that's the first test that I would do for EMI pre-compliance, and I can look at the settings here to see what kind of filters it does. This is things that it's a regular 100 kilohertz RBW with a particular span setup that's specified in the Bluetooth SIG. The next test that I will want to perform here for unintentional radiation when the device is powered in the RF measurements is called a spurious test. So I activate the spurious test, and the analyzer sets things up here for spurious test. The base configuration isn't terribly interesting, but if I load an FCC Part 15 mass test, and I want to adjust the reference level, I can perform the spur test. Now here I see a spur that spurs at 2.84 gigahertz, so it's at a harmonic of the intended band. I'm failing the spur test. So to be honest, what I really would need to do is modify the spur test to ignore the intended signal, a signal of interest. A couple things I want to point out though about the settings for the spur test. So it's looking from 30 kilohertz to 7.5 gigahertz. So looking up to the third harmonic of the 2.4 gigahertz ISM band. I'm using CISPR peak detect filters to do this quick sweep with the appropriate bandwidth setting for each of those, 120 kilohertz or 1 megahertz. The way the CISPR spec is written, these need to be 6 dB filters with a particular video bandwidth. And then the excursions for these have already been set up for this particular mask. But you can see here how I could edit this mask as I like by activating additional zones if I had them available and changing what types of filters I want to use, whether they be resolution bandwidth filters, 6 dB mil standard filters, or CISPR filter shape. The bandwidth, and then different limits for describing a spur signal and describing the limit for the spur signal in each of those zones. I have up to 20 different zones. In any case, here is the measurements here. Here are the measurements, and I have a table list of all the spurs that have been detected. This will find up to 999 spurs and their power level. So it's grouped by the power level of those, of the absolute amplitude of each of those spurs, and obviously the spur in red here is is failing the limit test. So this is the type of EMI test that I would need to do for unintentional radiated signals. This is a good conservative estimate. It gives me pretty good confidence in this case that I would not pass final EMI compliance, particularly because of this second spur here that's always present. So I'll have to go back and look at that design to make sure I can fix anything that's wrong there, or maybe add some shielding, or look at the leads. Maybe there's some pickup from a power supply. Somehow I'm getting a second harmonic there that's causing me to fail this EMI pre-compliance line. But in general, a CISPR peak-based search is a much faster test and a more conservative test to make sure I have good confidence to go past final EMI compliance, so I don't waste time in the compliance lab. I can figure this out in my own bench, provided I have enough shielding and not any other signals present that might cause me to fail the particular test. So hopefully that gives you a little better understanding of how to use a spectrum analyzer to perform EMI pre-compliance checks to give you better insurance for passing final compliance checks for your device under test. I thank you for your time.